Inverse trigonometric ratios. So far, you have used the sine, cosine, and tangent ratios when given the measurement of the acute angle theta in a right triangle to find the measurements of the missing sides. What ratios or values can you use when you need to find the measurements of the acute angles? We use what are called the inverse sine, inverse cosine, and inverse tangent values. These values can help us to answer the question above. If you know the measures of two sides of a triangle, then you can find the measurement of the acute angle. The inverse trigonometric values are given below. Remember SOHCAHTOA. So if sine theta equals opposite over hypotenuse, then theta equals sine to the negative 1 of opposite over hypotenuse. If cosine theta equals adjacent over hypotenuse, then theta equals cosine to the negative 1 of adjacent over hypotenuse. If tangent theta equals opposite over adjacent, then theta equals tan to the negative 1 of opposite over adjacent. This is a tangents table. It lets you find the angle if you know its tangent. For example, if you know the tangent of an angle is 0.606, you look through the table and you find 0.606, which is right here. And then you can reverse the procedure. You can see what angle it was. 31.2 degrees. So this gives you the angle, this gives you the decimal at the end. So the 0.2 is this 0.2 here. Use this sine table to find the angle whose sine is 0.125. All right, so we look here. All right, 0.125 is right here. Therefore, the angle is 7.2 degrees. All right, and as you can see, the angle is 7.2 degrees. Use this cosine table to find the angle whose cosine is 0.552. All right, I go through. Oh, there it is. 0.552 must be 56.5 degrees. So the cosine of 56.5 degrees is 0.552. And there's the answer, 56.5 degrees. To find an unknown angle measure in a right triangle, you need to identify the correct trig function that will allow you to find the unknown angle of interest. Use SOHCAHTOA to help. Let angle A be the angle of interest, which is right here. Label the two given sides opposite, adjacent, or hypotenuse. So we have opposite, adjacent, and hypotenuse. Identify the trigonometric function that uses angle A and the two sides. So here we have values here and here, so adjacent and hypotenuse. So which trigonometric function involves the adjacent and hypotenuse? That is cosine. So cosine of angle A equals adjacent over hypotenuse, which would be 9 over 15. Since we are given the adjacent side and the hypotenuse, the ratio we choose is adjacent over hypotenuse, which is cosine. Solve for the measure of angle A, the unknown angle, using inverse cosine. So cosine A equals 9 over 15. Therefore, the measure of angle A equals the inverse cosine of 9 over 15. Using a calculator, we see that that is 53.13 degrees. Once you find the measure of angle A, you can easily find the measure of angle C using the triangle sum theorem. So the angle here would be 90 degrees minus 53.13 degrees. Now let's find the measurement of the angle theta in this case. The sides that we're given are the opposite side and the hypotenuse. We'll use the trig function that relates those two sides to our angle. So if we have opposite and hypotenuse, that's sine theta. Remember, SOHCAHTOA, so is SOH, which is opposite over hypotenuse. Since sine theta is opposite over hypotenuse, that's 12 over 13. Therefore, we can do the inverse sine of 12 over 13, and we get that theta equals about 67.38 degrees.